week's problem, we have the challenge of writing null and alternative hypothesis, and each situation is different, so that's what's going to give us the hints. Now, just to remind you of a couple of things, the null hypothesis really is going to be contrasting with the alternative hypothesis, and the null hypothesis is often the standard, no change from traditional values, no effect. It's really the no relationship, no difference. Everything is the status quo, is what the author refers to it as. So the alternative hypothesis oftentimes is a purpose for which we are doing the experiment to conclude that something is different. And what is different? What is the claim that is being made? That is often captured in the alternative hypothesis. And a couple general tips on writing those is, one of the things that we need to see is that in a null hypothesis, it's always going to have the less than or equal to, the equal to, or the greater than or equal to sign. So all of these involves the equality in some way, and the choice of less than or greater than or just straight equal to is dependent on the problem and what it states. The alternative hypothesis, and just to remind you, which I think you would have known from reading the text, that we use H0 to denote the null hypothesis. The alternative hypothesis is going to be the complementary situation or complementary statement, and in that case it's going to be either greater than, not equal to, or less than. There are no other options for this. It cannot include any equality. The equality is always on the null hypothesis side, either less than or equal to, straight equal to, or greater than or equal to. So it's three possibilities, which all includes equality for the null hypothesis. Now, the alternative hypothesis is written as HA or sub A, and it must be true if H0 is false. So that's what you want to remember. So if we were to get back to what the problem is asking us to do, in the first instance, what we want to see, the alternative hypothesis would suggest that since they want to see that it's at least 93, the alternative hypothesis is going to be that it's greater than 93. And I start there because it's easy to see that. Now, coming back to the null hypothesis is just going to be saying that the proportion of stuff delivered on time is 0.93, and the alternative is going to be suggesting that P is greater than 0.93, where we establish P as that proportion. So this is going to be the response for part A. Question B is stating that a realtor company recently announced that the proportion of houses taking more than 4 months to sell is now less than 56%. So again, we're going to be using the value P, or the variable P, to represent the proportion of houses sold within 4 months. So therefore, HP is equal to 0.56, and the alternative, they are suggesting that it is now greater. So what they're saying is that P is actually less than 0.56. So it's saying it's now less than 56%. So in other words, the realtor company wants to suggest that houses that are taking more than 4 months to sell is less than 56%. So the proportion would be less than 0.56. So HA's P is less than 0.56. In the last part, financial firm accounting reports have an accuracy of above 96%, and again, we're going to use P to represent the proportion. So P is equal to 0.96 is the status quo, and we're saying or wanting to test that the accuracy rate is above 0.96. So the alternative is going to be HA is P is greater than 0.96. So just to recap, the null hypothesis is going to represent the status quo. The alternative hypothesis is going to be what is the complement of that, and we always include the equal sign in some way in the null hypothesis, and the alternative is the opposite of that. So that's it for this problem. If you have any questions, please feel free to reach out to us. Okay, thank you.